Right, guys, so we are on question 4.1 of the IEB 2022 stats exam. And you were given probability distribution of a discrete random variable x is given by this over here. Right? So we're told that over there. And the first question was going to find the expected value or the mean of this discrete probability function, otherwise known as a probability mass function. Okay. And E of x is simply going to be equal to the sum of each individual score times by its probability. So it's going to be 1 times 0.3 minus m plus 2 times 2m plus 3 times 0.7 minus m. And you go do the maths, distribute, and you end up, the m's will cancel out, and you end up with an expected value of 2,4. Okay. Right. You couldn't actually find m just by adding up the probabilities here. Okay, and say that the probability, often a technique is we add up the probabilities. Okay, we say that they must be equal to 1, which is true, and then we solve for m. The problem with this question is that the m's cancel out. Often they won't. Okay, so that's your first strategy if you're finding a variable. All the probabilities add up to 1, but it wouldn't have helped you in this particular case. The next question says, find the possible range of values of the constant m. Okay, so a range of values. So we're going to use, there are shortcuts for this question. I'm just going to show you the long way of thinking about it. Okay, you could just work with the fact that you know that you're only going to have positive values because that's 2m, and then therefore 0.3 minus m must be less than 1, and that must be less than 1. Okay, but just to show you the full explanation of it, well, your individual probabilities, okay, must lie between 0 and 1. So first of all, 0.3 minus m must lie between 0 and 1. Okay, move negative, to take away negative 3 from 0.3 from each side, divide by a negative, and we end up with m must lie between 0.7 and 0.3 for this particular probability. Okay, for this particular probability over here, well, your probability is 2m, so 2m must lie between 0 and 1, divide both sides by 2, m must lie between 0 and a half. Okay, and for this particular probability over here, 0.7 minus m must lie between 0 and 1. Okay, take away 0.7 from each side, and I end up with m lies between negative 0.3 and 0.7. So where do the regions overlap? Okay, so if I look over here, I take this bit over here, and I go, right, first region, okay, as I say, there's shorter ways of doing this. Your m values can lie between negative 0.7 and 0.3. Over here in green, your m values lie between 0 and a half. And over here, okay, for this particular probability, your values of m must lie between negative 0.3 and 0.7. Okay, so then overall, where do all three regions overlap? All three regions overlap here. Get all three regions there. So in other words, m is stuck between 0 and 0.3. So that is my range of possible values for m. Okay. Right. The next question says, given that the variance is equal to 0.72, find the value of m. So if you go to your formula sheet, you've got the variance is equal to the expected value of x squared minus the expected values of x all squared. So the variance of x is over here, which is 0.72. The expected values of x squared means you've got to go square your x values. It's the sum of your expected values of x squared. Okay, so e of x squared. So to find e of x squared, you're finding the sum of your x squared values times the probability. So it's going to be 1 squared times 0.3 minus m plus 2 squared times 2m plus 3 squared times 0.7 minus m. That's what e of x squared means. Square your x values and times it by the probability and add them all up. Okay, so that's e of x squared is that whole thing over here. Okay, and then you've got to take away e of x squared. Well, we worked out e of x was 2,4. So e of x squared is going to be minus 2,4 squared. And if you go distribute, you get that whole line over there. This line here. Okay, just by distributing, negative 2,4 squared is negative 5,6. Get your constants to one side, it should work out to negative 0.12. Keep your m's on the right, negative 2m, divide both sides by negative 2, and I end up with a solution of m is equal to 0.06. Okay. Don't forget your formula sheet for these probability mass functions and the fact that each individual probability must lie between 0 and 1, and that your sum of your probabilities is 1, although that didn't come up in this particular question over here. Okay.